Good afternoon. Uh, I've been thinking a lot about wave energy and a lot of different wave energy type devices keep popping up in my Facebook stream on the climate change mitigation adaptation Facebook group. And it really had me thinking a lot about how this technology works. It's something that I'd heard about, years and years ago. I guess when I first saw the movie Home, that was probably the first time I'd ever even heard of the concept of trying to harvest ocean waves for electrical generation. And it always seemed, like, kind of out there, obscure, like, really, we're going to spend all this money to invest in ocean infrastructure. But now that I've taken the time to look into, one of the technologies that really fascinates me, that is the Carnegie Wave uh, device, which is here in this picture, obviously. And I've also learned quite a bit about mariculture and aquaculture recently. It seems to me that there are a lot of really interesting, unique potential to wave energy, and it's because wave energy and the way we develop it offers a lot of carbon sequestration and ecosystem type services that don't really have an analog in wind energy or solar energy. I mean, you put up a windmill, you put up a solar panel, the effect that they have on the environment, it's kind of negligible. On the windmill, it's arguably kind of bad because there's a lot of different statistics and things people say out there about windmills killing birds. Solar panels really don't have much of an effect on the environment at all. Assuming you're building an independent solar panel, factory or not factory, power plant like out in the desert. There are people who say, well, that affects the desert. It shades all this land. It occupies all this land that desert tortoises and hares and other uh, you know animals in that ecosystem do. So potentially negative. I don't know. It seems negligible to me. But on the other hand, if we look at wave energy and we try and integrate it with mariculture, with integrated aquaculture, or with some different ecosystem services, there's a lot of potential for wave energy to not only generate carbon neutral electricity, but to support a lot of carbon sequestering and carbon negative natural ecosystem processes. Now, I'm going to speak specifically about the Carnegie Wave because this is the one to me that seems most interesting. And basically, what they've developed here is a type of tech where they have these large floating buoys that are underground, or excuse me, underwater, submerged, and they're anchored to the ocean floor, and they bob up and down with wave currents that move through the area. And when they bob up and down, they pump water through an underwater pipe or under seafloor pipe, pumps it all the way up to on floor. And because that water comes through with so much pressure and so much strength, that water can be pushed through a series of membranes to produce desalinated water, to produce reverse osmosis desal water. And this is really, really interesting to me because there's potential here to create carbon negative or carbon neutral, low energy use uh, desalinated water, which fresh water is one of the big shortages that we have. And I'm going to have a whole other video talking about why we need to really uh, make an investment into desalination. And there's a caveat there. If you go into desalination, you need to make that investment with a lot of that desalinated water reserved for environmental use, for ecological restoration, for afforestation and soil building and growing soil building plants, etc., etc. But anyway, so their model here shows that water coming in, it can be pumped through the membranes to produce desalinated water, or it can run through turbines to create electricity, which goes back to the grid, and then it returns that seawater back to the ocean. Obviously, there are the environmental impacts of the intake valves here, potentially doing damage. So, we need to be very sensitive, and it's the same thing with any desalination plant, the intakes and the outtakes of where the brine water and where the ocean water comes in. They need to be properly maintained and guarded so that they don't affect too much of the ocean life. But the big thing that I think about here is that these large floating buoys also become places for us to mount seaweed, longline seaweed farming things, or we go in here. Here's an underwater picture of the guys like installing these things. Carnegie is an Australian company, and their first buoys have been installed in off the coast of Perth in Australia. There's a certain place where there's a lot of wave activity where they're installing the first of these, and they're creating creating power to run a desalination plant. But the first thing I think of where there's integration here is a technology called Biorock or Seacrete. So basically, what you're looking at here, these are metal anodes that are carrying a very light electrical current, and the electrical current causes different minerals in the seawater to condense out. So what you're looking at here is a very light, very weak electrical current is making calcium, magnesium, and different things condense out of the precipitate out of the ocean water, and then that becomes new food for corals. So in different places where they've set up these biorock and Seacrete features, there'll be places out in the tropics where if a diver goes around and sees like a sick, um, dying coral, they'll grab it and they'll slap it on here, and they'll just start growing back because all of the precipitated calcium and magnesium on the biorock, anode, is like baby food for them. They can uptake it, and then you see the picture here. You're already creating a very diverse, rich reef. So if you've got an underwater buoy that's just bobbing up and down, creating electricity out there, and you've already got access to electricity, why wouldn't you take all this area around it and make these biorock reefs? You've got a little bit of power. It doesn't take much. It's a very weak current, just enough to cause this precipitate to form out, and you could cover all this land area around these bobbing electricity generating buoys. I have no idea how to pronounce that word, and create some really nice reefs. And it could even be a tourist attraction depending on how you design it. Obviously, you might have to think about like the safety of how much these things wiggle and move around, but possibilities out there. The other thing is, here's another picture of a really, really cool biorock reef. I mean, corals are beautiful, and it's really, really unfortunate that ocean acidification and rising ocean temperatures are making it difficult for them, because they're the source of so much of the diversity in the ocean. And basically anywhere where there's life, anywhere where there's a lot of biodiversity, that represents a sink of carbon. So if we can create biorock reefs like this that harvest a nominal amount of power from these buoys, we'd be able to create beautiful reefs like this. And I think that would do a lot for helping us to sequester carbon and start to bring the acidity of the ocean, solve the ocean acidification problem. Another thing is seagrasses. Obviously, there are pictures here all the way back here, and their concept art. They've got seagrasses already planted here, and there's a study. I'll put a link to it out of Korea where they show that they can that artificially created and planted seagrass bed, or a sea meadow, I guess you would call it, can sequester 10 10 tons of carbon a year, 10 tons of carbon per hectare per year. So, again, it comes to the economies of scale. If you're already sending guys like this down there to install this, you've already got the boat out there, you've got the crew. How much more does it cost to put, a few more guys that'll plant seagrass, assuming that you put these on in some part of the ocean, or where it's just blank seashore or it's empty. So if we can create more seagrass environments like this is another huge bed of biological activity, of ecological diversity, another really big carbon sink, and I'll put that link um, in the more info below. The next ones is longline kelp farming, oyster sea fish farming, or shellfish farming, integrated mariculture. Again, if you've got these floating pieces of machinery that you've spent so much money already into installing, what's the feasibility of adding more functions onto them? So it bobs up and down, it creates electricity, but it's also an anchor point for putting on a long line of growing seaweed. And seaweed or shellfish, these are mussels, filter feeders, and this is where you can really get into just stacking functions on top of one another, because you go to a place like Gulf of Mexico, where there's a lot of dead zones going on because there's these algal blooms. So we put these platforms out where we harvest wave energy, and then we put long lines of kelp there because there's so much nitrates and nitrites and ammonia coming out of the Gulf. These can help absorb them and mitigate some of these microalgae blooms that are creating these dead zones. And then you also farm shellfish that will be intaking through their filter feeding process those algae. And I would suspect, because this this buoy whatever, it functions to harvest energy. If you put all these different floaters on it, then wouldn't that create more resistance? So if you have all these long lines of oysters, mussels, kelp, whatever, all affixed to it, and they're all out there, that means that all those things are transferring more of that energy through those lines to the ultimate buoy, so they might be more efficient with all these little hangers on at harvesting energy. Of course, it could also work against them with all these lines out there. It could get tangled, or it could, have more problems with maintenance. Obviously, I'm not really like an engineer or an economist, so I haven't looked into all these things. These are just some of my thoughts, just looking at these systems. And really, what it comes down to, when we talk about environmental sustainability and ecology, one thing I've learned from like permaculture, which I think has some of the best systems for us sequestering carbon on ground, because all permaculture systems so far on ground, is that integration is how we're going to get out of this mess. And compartmentalization and separation, and the economies of scales and the whole factory model, while that was able to get us through industrialization and able to get us mass production, it's also where we had to cut a lot of corners, and a lot of the detrimental environmental effects uh, of raising cattle, or of growing huge fields of corn or soybeans or whatever, really started to leach out into the environment. Because when you have integrated systems, the waste of every different product you make is a feedstock for the next thing, and it goes in a circle. Well, here, there isn't much of a drawback to the wave energy harvesters. They're pretty environmentally friendly as they are, but if we can tack more things onto them, we can make them net carbon negative as opposed to carbon neutral. That would be a really good process for us to start getting the carbon out of the atmosphere, getting us back to 350 parts per million, or 280 parts per million, or wherever we think we need to be, wherever scientists determine we need to be to stabilize our climate to a more sane role. So those are just my thoughts on how we can integrate these technologies. There's a lot of really cool stuff to be done in the ocean. I'm going to have to make a whole another video on my ideas and thoughts and reactions, I guess, to multi-trophic integrated aquaculture, which is a really fascinating field. But it's all the information, all the thoughts I have for this video. I hope you found it interesting and informative. West Coast.